Hi everyone, good to see everybody. Today I'm going to go through costs, revenue, something about perfect competition, a little bit on monopoly and monopolistic competition. I have a great set of questions. Unfortunately, I don't actually have any official solutions to these, so I wasn't able to 100% verify my answers. I have sent on the link attached below. I've written my own answers and I have tried to justify why I think each of them is right, or giving my best shot at it. Take a look at it. If you think that the answer is different, leave a comment in the description below. But it should be reasonably okay, I guess. But you should be able to see where maybe my reasoning is going wrong. Okay, so question 1. Here we have a sports center. Have a read through that. It's got answer B in it. Ignore that one for now. So this is a standard question. It's asking about when are they going to be a profit maximizer? And all you have to remember is if you profit maximize, you are going to produce, and it's really important, you have to produce at the quantity, at the quantity where MC equals MR. So I like to highlight my MC curve because I'm not very good at seeing lots of things at the same time. I highlight them, MC, MR, and they cross right here. And remember, it's not that point, it's just the quantity. So this company is profit maximizing at output B. Just for the record, what price would they charge? You want to charge the highest price that consumers are willing to pay. And what they're willing to pay is shown by a demand curve. Demand curve shows that. So what you need to do is go up from B, charge the highest price that consumers are willing to pay. So just for the record, the profit maximizing price would have been P1. Anyway, that's that one. Let's move on to the next one, which is not there. Okay, question 2. Which is closest to the model of perfect competition? So I'm not going to list all the characteristics, but you're looking for something where you're selling the same products, everyone's selling the same things. So I'm going to exclude software. There's antivirus software, there's a whole bunch of different software. I am going to exclude cars. Yes, cars can be somewhat similar, but you've got electric cars, you've got non-electric cars, you've got SUVs, all kinds of things. And coffee is kind of the similar products. Obviously, there's some variety with different brands and stuff. But the issue with coffee is that it has some barriers to entry. If you want to start a coffee shop, be prepared to pay £100,000 to start off that shop with all the marketing and stuff. So I'm not going for that one. For the same reason I'm not going for rail. Be prepared to spend billions. That's got even more barriers to entry. Now the foreign exchange market is where you can buy and sell currency. All you need to do is start up an account. I think in some cases you need to be over a certain age, and there might be some exclusions based on some countries, but you need very small amounts of money to get started. You need just an account, just an internet connection, and that's it. There are no barriers to entry, and everyone that's buying and selling there, buying and selling the same US dollars or Great British pounds. Question 3. I love question 3. It is a good test. You'll be surprised how easy it is to get this one wrong. This one's asking you for the MR, but it's been geared up in a way that makes you intuitively work it out and think, whoa, they're selling one extra cake and they're selling it for $1.98, so they must be getting kind of like $1.98 more in money, or something like that. Something like that happens. Don't do it intuitively. Actually write down the equation. So MR change in total revenue over your change in quantity. And I know this is maybe I wouldn't say it's boring, but it takes a few more steps. Change in total revenue, you have to work it out. TR2 minus TR1. So then take the time to work that out. Take some time, but you will not be getting it wrong this way. So TR2 is P2 times Q2, which is 198 times 51. TR1 is P1 times Q1, so 2 times 50. Go through all those steps. The change in total revenue will be 0.98 The change in quantity here is just 1 unit. They've gone from 50 to 51. So you put this into your equation and you get 0.98C. Okay, when I see a question like this, there's a lot of lines and the lines are very complicated, average cost, marginal costs. So I have some explanations in the document below, take a look. But the way I would solve it quickly is just draw it. Draw your average costs, draw your marginal costs, and then you can see way easier. Go through it like one by one. So average costs always rise. So I would highlight this. So average costs are rising here. When marginal costs are rising? No, marginal cost is rising for all of this. So there's a whole bunch of quantities, all these quantities where that's not true. So you can eliminate A and repeat for the rest. And when you do all of this, you will find that the answer is E. Here in this section, average cost is on its way down. Do you see that there? Average cost is falling, but marginal cost is rising. That's the opposite. The explanation for that, because you've got a little couple lines here to explain it. Now that one's a little bit harder, but that's okay. So all you need to do is remember that if your marginal cost is on its way up, that's because there are diminishing returns. But here's a tip. Diminishing returns only impacts your marginal costs and your average variable costs. So when there's diminishing returns, you'll get an increase in your average variable costs. The trick is to remember that your average cost is both your variable costs and your fixed costs. And I don't even remember this, but you will have average fixed costs always and always falling on this graph. It's not on the graph, but you can infer that because there's always more quantity, but the fixed costs are the same. So average fixed costs are on their way down. And the thing to remember is average fixed costs, they fall really, really, really fast in the beginning. They fall super fast. So what is going to happen, average fixed cost is going to be falling super fast. Yes, your MC is increasing, so your AVC is going to increase, but not as much. And then that is why your ATC can fall. You'll see that in more detail written down there, but the graph itself should help you get the right answer. Just the explanation can be a little bit trickier. Okay, this question surprisingly catches out a lot of people. So take a read through that really carefully. They have given you all the information you need, it's just not very clear. So the key thing to see with this is that Newcastle, Scottish and Newcastle, whoops, can't see that. Scottish and Newcastle, they are not acquiring a rival brewer. So we can infer that Scottish and Newcastle is a brewing company. In fact, they are a beer brewing company. So in terms of the supply chain of beer, where you would have beer, people would have beer in a pub or a supermarket or something. Beer is first grown as hops, then those hops are processed by a beer brewing company. And you add water and all kinds of things. Then that beer gets transported by a distributing company and it gets taken to the pub or taken to the supermarket. So that's how I envisage a supply chain. So right now, this company is a beer brewer and it says that they are buying a distributor. So they are buying this one. So they're going along their supply chain, specifically they're going forwards. So this is the type of forward vertical integration. Okay, revenue maximization. Let's draw a graph. Let's see what that means. So you want to produce at the point where your total revenue is the highest it can be. And in this particular graph, it would be here. this is your quantity revenue max. Some total revenue curves, just for the reference, don't work out that way. For example, this total revenue curve never has what we call a mathematical maximum point. There's no turning point, there's no peak, there's no flat bits, there's no maximum. This curve can keep going and going and going forever. So just for the record, revenue maximization is impossible in this bottom one, but it is possible in this one. It's specifically right there, right at the top. So the gradient at this maximum is 0. There's a few ways you can see this, but the way that I'm going to do it is based on this. The gradient of this total revenue curve is 0, and you're not aware, your MR grabs the gradient. Your MR is how much your revenue is changing by. And at this top, there is no change in your revenue. It's flat, 0 divided by X. Your MR is 0 right at this quantity. And that's a quick way to identify that maximum point, the point itself. So you want to be producing at E, where your MR is 0. I think we'll talk about that a little bit more today probably, but maybe in another video. So let me know if you want to look at that in more detail. Also remember to look at the document below. Okay, this one is also a super tricky one, so take a break with this, grab some tea or something and really work on this before you look at the solutions. It's a great question, and if I'm honest, it just tests your definitions. The problem, I think, this is my opinion, I think this question gears up the answers to trick kind of your brain. So if you look at this, they're only asking between A and B. And between A and B, my brain thinks, okay, this is flat. You'll be surprised how many people answer flat. Just flat. They'll answer B or they'll answer D because they look at it, it looks flat, so they think, okay, average cost must be flat. So be aware that your brain might get tricked a little bit, and remember to just go down with the equations. Don't try and do it any rule of thumb kind of way. So let's start with marginal costs. So marginal cost is your change in total costs as you change your output. Now I can literally show you this with maths, but let's see how it works without maths. So to work out the change in total costs, I need to know what the total costs were at A, and I need to know what the total costs are at B. Total costs at A are here, total costs at B are there, and you can see they're exactly the same. That's the same, and that is the same. So whatever they are, and you're not given any numbers, this is another hurdle, you're not given any numbers, so your brain's like, oh no, how do I work this out? You don't need to, you just need to know they're the same. So your change in your total costs is 0. And I don't even need to know what the quantity is changing by. Let me just give that a random value of y, because there's a maths rule. So it's a maths fun rule that if you ever do 0 divided by anything, you get 0. So long story short, you just need to look at the graph, see that total cost is not changing, and that's enough information for you to infer that your marginal cost is 0. So that's the answer. Now let's just try and work out average cost just for curiosity's sake. So gotta make some space. Hope you save that one / go back. Okay, now your average cost, do it with the equation, way more reliable. Total cost over quantity. So the average total cost at A is your total cost at A divided by your quantity at A. Now this is kind of repetitive. Average total cost at B is that one over that one. But we know that the total costs are exactly the same. So I'm just going to delete this for now and just say these things, whatever they are the same. The only difference between these costs is the quantity. But we know that the quantity at B is higher than the quantity at A. So therefore, the average total cost, if we look at the equation, at B is smaller than the average total cost at I know I wrote down the same thing, at A. So, your average total costs has been falling between A and B, and you actually don't have that as an option because the answer was A. That's a good one. Okay, long run perfect competition. I'm just going to draw it just so you guys remember. You're going to end up with a demand curve. Well, that's equal to your AR and your MR and things. That's going to be equal to your price. And you're going to have a situation where you're only going to make normal profits. Normal profits are made when you're charging the same price as your costs. And the only way for that to happen is if your average cost is like on the demand line. So demand line is equal to price. So in the long run, this is going to happen. So there's a whole bunch of options, but you can just learn normal profits in the long term. This price is equal to your average costs. They've written down a couple of other interesting things here. They're all wrong, but we can talk about them. So just for reference, perfect competition is always allocatively efficient. Always, always. I've explained that in the document below. In the long run, they are productively efficient because they are producing at the minimum of their costs, so they're not wasting anything. And they are covering all their average costs. That's made up of your average fixed costs and your average variable costs. So that is very untrue. Okay, this question, I think, is one of these questions where there's so many options and the options are so long that it's difficult to get the right answer in the first place, but then it's also difficult to get it in time. So here's a couple of rules that you can just learn. If you have a downward sloping demand curve, just memorize. This is all you need for this question. Just memorize that your MR curve looks like this. In other words, your MR curve has a section, the first half, where it's above the axis. So that's going to give it a positive number. Could be like a 5 here at the top, and then it could be like a 2. But it's going to always have that positive number. Then later on it has this negative number. That's all you need to work this one out and see that the answer is E. Just for the record, this point where your MR cuts the axis 0 corresponds to the midpoint of your demand curve. And that midpoint has a PD of -1. This bit has a PD that's elastic, and this one has a PD of inelastic. I know that one can throw you guys off a lot, but if you just remember that, that will also help you to see that B is just not right. Okay, this next one is talking about a company with a demand curve, D equal to AR equal to MR, and that's also equal to the price. It's only one type of market structure that you learn in year 13 that has that, and that is perfect competition. Monopoly has a downward sloping one, and same with monopolistic competition, and in both of these cases the MR has split off that. Now here, profits, I like to give you guys as much explanation as possible. You won't need that when you're actually working this out, but it'll help you understand it for now. So profit is the difference between your revenues and your costs. I like to split this up. I know some people don't like to do this. For me, I'm a little bit more math oriented, and it helps me understand this. So profit is equal to the difference between your price and your costs, your profit margin, and then you multiply it by how many units. So the price, we're assuming this firm profit maximizes, so MC equal to MR, kind of a wobbly line, produces at Q1. At Q1, the price is there, and the average cost is there, which is here. So your profit margin is the difference between your price and your costs. Multiply that by how many units are sold. This is the total profits that the company makes. So this is an area that you can actually shade in. When it's normal profits, you can't shade anything in. You're kind of breaking even from a total revenue and total cost perspective. So that's super normal profits, and the answer I would say is B. Okay, this one is a good question in the sense that you can literally work this out. It's asking you about marginal costs and it's asking you about average costs. So if you have any doubts, work that out. Marginal cost, average costs. Marginal cost, your change in total costs, which is 6,000, divided by your change in your quantity, which is 1. And then you can work out your average costs as total cost over quantity, so 8,000, and not too sure what this is, but I think it's like 7,900-ish, or a bit lower. So then the answer is going to be your marginal cost is lower, but rising. C. Marginal cost is increasing, but at all times it is lower than the average. Got the explanation for that below. Sorry, I didn't say. Okay, this next one is about monopolistic competition. You might not know what that is yet, but it doesn't really matter. You can still answer the question because you know this company is profit maximizing. And if they're profit maximizing, they are going to be producing where MR equals MC. So that will be producing at E. You know that they'll be charging the highest price that they can that consumers are willing to pay. So you go up to the demand curve from E. Demand curve is this one, they're a bit sneaky, they haven't said it. And they're charging a price of B. And here they're asking you, what is total revenue? So you need to do what is price times quantity. Price is B, quantity is E. Unfortunately, they don't actually give that as an answer, so here's what they've done. So B, price B, is the height of a rectangle, and E, or OE from the origin to E, is the length. If you multiply these, you get the area of the rectangle, and you also get the revenue, because the revenue is B times E. So we're looking for a rectangle height B, width E, and that is BGED. So that's a good trick. You can always work out total revenue as an area of a rectangle. Okay, this next one is another acquisition question. We have to identify, are they buying a company in a supply chain? Are they buying a competitor, something totally unrelated? There was some doubt with this one, but I wasn't sure whether these companies were already a conglomerate, but I don't think that mattered very much because both of them have hotel companies right now, and both of them are selling their hotel companies right now. So they're not expanding into any other industry that they're not in right now. So it's not conglomerate. I would say they're buying a competitor, so I would call that horizontal integration. Okay, question 14 is actually a really useful question to practice. Here they've actually done a lot of the hard work for you. You might actually come across a question like this yourself when you're writing an essay. You're talking about policies to regulate a monopoly, and you decide to talk about a tax or a fine, some one-off fixed cost. This is a fixed cost. Anyway, imagine you talk about it in your essays and then you've actually got to draw it. And it can get tricky because there are certain rules to learn. Luckily, they've told you what happens. So they've told you, okay, you've increased your fixed costs, and they've told you that that's going to increase your average costs, but your marginal costs are going to stay the same. That's AC1. This is kind of AC2. So they've done all the hard work for you. They've actually told you this is what happens. That's something for you to learn. If you increase your fixed costs, increase your average costs, but do not increase your marginal costs. And it still has to be the case. I kind of maybe missed it a bit here, but your marginal cost has to cut the minimum of those. Maybe I'll explain that to you in a different video. But the short answer is your marginal costs doesn't have anything to do with your fixed costs, because your marginal cost is your change in your total costs. Sounds like it has something to do with your fixed costs, but it doesn't, because it's only the change that varies with your quantity, and fixed costs never vary with quantity. So that's my explanation why your marginal costs don't change if you're changing your fixed costs. So the implication of this, if you were to actually draw the graph, your MC and your MR are unchanged. And so Q1 is going to equal Q2. There won't be a Q2 because it's the same. And going up to the demand curve, charging the highest price, P1 is not going to change because the price comes from the quantity that you're selling. So that's unique. If you change your fixed costs, your average costs increase, your marginal costs don't. And your price doesn't change and your quantity doesn't change. But you do have higher costs. So your costs were here before. So you were making this much profit margin for that many units. This was your profits originally, and now you're making that same price, but your costs are down here. So you're making a lot smaller profit. It's just that shaded area now. So output is the same, price is the same, and your profit has fallen, giving you the answer of C. I think I've explained that. There's a bit more detail. I didn't add the diagram. The diagram really helps, but it should explain those concepts a little bit more. Okay, this one I found a little bit confusing, but here's my thinking, and you might disagree with me. So Kelso is a private equity company, and private equity company, think of them like companies that buy other companies to refurbish them, to improve them, or tear them apart into chunks and resell them. So they're like your home renovators, people who make money from renovating houses. They kind of make their money from renovating companies or improving companies or tearing them into chunks, like into flats or something. That's kind of what a private equity company does. So you've got to have quite a good business acumen to know the value of what you're buying, to like envisage what it could possibly become, and you also need probably a good finance background to finance all of that. So that's a private equity company. So immediately when they're buying a company, I'm thinking, okay, they want to make a profit. They see a profit opportunity. So they want to buy Nortec, and this is a design company and a building company. And I was going down the list and I was thinking, okay, what kind of profit opportunity could they be seeing in Nortec? And I saw the idea that they could have diseconomies of scale. Now this is a bit bizarre because usually diseconomies of scale are a bad thing, right? Diseconomies of scale make you operate on higher costs, and they're bad, which means it's a profit opportunity. What if Kelso buys Nortec and scales down the business. So for example, imagine it demerges the design company and splits it apart with the building company. Now that it's a smaller company, there will be less diseconomies of scale. So that means the building company will be a lot better run, it will have lower average costs, and maybe it's going to trade at a higher value than before. So this Kelso company can make money. So I reckon it's D. Okay, question 16 is talking about a company with a downward sloping demand curve. Just for the reference, your AR is equal to your demand curve. The explanation for that is kind of a bit odd, I guess. Your demand curve is the relationship between price and quantity. Obviously that's simplified. Don't write that down. That's kind of what it would be in maths. And your AR curve is like your AR plotted against quantity. But you know that AR is TR over quantity, and you can split that into P times Q over quantity. Quantities cancel out and you're left with price. So plotting AR against quantity gives you the AR curve. But since your AR is equal to your price, it's kind of a long explanation just to explain why AR equals D, but it's the same thing as plotting price against Q. So it literally means the same thing as your demand curve in this context. Anyway, that's just a bit about that, side note about that. So when this company has a downward sloping demand curve, remember that your MR looks like this. So I'm looking for something like that. Oh, and also, I don't have any space here. Downward sloping demand curve company will have a total revenue curve that looks like a mountain. So total revenue first increases, then decreases. So it is not D. Margin revenue is not equal to 0. It goes from positive numbers to some kind of negative numbers. Is there another option? Yeah, I cut it off. So the answer is E. Positively increases, total revenue decreases. That's just something to memorize. That's what your AR and MR and total revenue looks like. Okay, this question, we have a monopoly who is producing at costs higher than their revenue. And what this is going to mean is their profits are going to be below 0. If you have any doubt, you can write that down. So your profits is your total revenue minus total costs, and a way to write that is your average revenue times your quantity minus your average cost times your quantity. So you can see average revenue minus average costs. It's basically your profit margin, times it by your quantity. So if AC is greater than AR, your profits are going to be smaller than 0. Also, the question tells us that this company is profit maximizing. They have marginal costs equal to marginal revenue. This means it's a bad situation. They're making a loss, subnormal profit, but it's the best given their circumstances, so they're in a pickle. So they cannot change their profits to be any better. They are making a subnormal profit, not supernormal. Normal profit would be if it equals 0, so you're left with E. Okay, this I think is my favorite question in terms of questions to test you before your exam. Have a go with this one. Again, don't look at the answers, it's not worth it. It's really good to catch out anything that you can still get tricked by, I guess. But the trick with this is to remember your definitions. Remember your definitions of AC. Remember your definitions of AC. It's just a definition question. So looking at the answers, they've really gone an extra mile to kind of, again, do that thing where the graph looks like it's something. So the graph for all the quantities that they're talking about, J, K, L, all those quantities, graph is like going down. So you always think falling, or minimize. So it's easy to pick these, but they're all wrong. Here is how to see why that is the case. Total costs is your fixed costs and your variable costs. If you want to minimize these, remember that you don't pay any variable costs if you don't make any cakes. So to minimize your total costs, only pay your fixed costs. Produce zero output. Here's another way to see it. If you want to produce more cakes, you're going to need more eggs and more flour, so you are going to need to pay more variable costs. So as a rule of thumb, if you want to increase your quantity, you will always face higher total costs. So that means the costs at K are higher than the costs at 0. The costs at K are higher than the costs at J. And the costs at L are higher than all those costs too. Here's another way you can see it. For all of these quantities, I know your MC is doing some weird stuff, going down and it's going up, but for all of these quantities, your MC is a positive number. Now, that means that your MC first increased by 5, then increased by 3, then it's 5 again. So imagine your total costs are 105, they would be 108, and then they would be 5 higher, they'd be 113. So you've got 3 ways there to make sure you're not getting caught out by that one. Okay, so the total costs are rising between J and K. Why? Because your marginal cost is positive. Or because you're paying more variable costs, because you're making more output. Okay, so sales maximization. This is the idea that you want to produce the most quantity. How do you make the most quantity? Well, you want to charge the lowest price that you possibly can. But you've got to still stay in business, so you don't want to charge such a low price that you're making a loss. If you do make a loss, you could also get sued because that could be considered predatory pricing. So you want to charge the lowest price, but you have to not go so low that you're making a loss. So until you make no more profits. So normal profits meant that your total revenue minus your total cost equals 0. You just kind of broke even. So again, remember if you did some rearranging of this, that's essentially saying your average revenue minus your average cost times your quantity must equal 0. So this will equal 0 if your average revenue equals your average costs. That's how you find this sales maximizing point. Okay, Monopoly is making supernormal profits and it's got an increase in wage rates. So its variable costs are going to increase. So its average variable costs are going to increase. And that means its average total costs are going to increase. Just for the record, when your average variable costs increase, your average total cost increases parallel. Hopefully I'll show you that another time. So ATC1 has gone to ATC2. There's another thing though. If your variable costs increase, watch out, your MC increases, and that's also going to increase parallel. So imagine this is MC1, shifts up parallel to MC2. MC1, MC2, and you should still have the minimum kind of like working out on the AC curve. Luckily, again, they told you that in the questions, you didn't have to work that out, but to actually get the answer, you will need to draw on your demand curve, draw on your marginal revenue curve, work out the profit max quantity, and I know there's a whole bunch of things on here, so you'll have to work this out slowly yourself, or just trust me with this one. The quantity is actually going to fall. Price, you go up to the demand curve. That's P1, P2 is higher. So price increases, output falls. And your profits are going to be smaller. I'm going to shade them in before. So a good thing about these questions, you can always work it out if you have any doubts. So the answer is C. Okay, this one, total revenue is increasing at a constant rate. So your change in total revenue is always the same as you change quantity. So your MR is always going to be the same. So we're looking for a constant marginal revenue. And if you increase your total revenue by the same, 10 each time, and you worked out average revenue, since average revenue is total revenue over quantity, which equals to price, it is always going to be the same. So you can literally work it out if you have any doubts, but you can also just remember that a perfect competition firm has average revenue constant, marginal revenue constant, and a total revenue curve like that. Okay, this question, we have a soap company. Wait, how do I? Kind of like a soap and homeware company buying a razor company. I think they're very different industries. So that's basically the definition of conglomerate integration. Okay, this one confused me a little bit with the phrasing. You are dealing with an internet security product, software. Software is pretty much made before you sell to the first customer. And the software, I mean, there's some updates every year, but remains the same whether you're selling to one person or 1,000 people. So software has a lot of upfront fixed costs. So the companies will need to buy more, pay more fixed costs. Hopefully it makes sense because you average out, I mean, you can have this great multi-million-pound internet security in a company, but it turns out to be kind of cheap for the company if you're doing that over millions of units of output. This one, I don't know how many of you have heard of Safeway, but yeah, it was an old supermarket that merged with Morrison's, and I think I nearly got tricked with this one. So I'll tell you why. So Morrison's grew to become 13.9% market share. So they have less than what's required for a monopoly power firm. That would be around 25%. Usually I would think, okay, mergers, you want to gain more power in the industry. But no, I don't think so. With this one, you don't actually gain monopoly power. So they must be thinking of some kind of other reason. And the one I think that made more sense was C. The idea if they merge, they're a bigger company and they can get more bulk buying discounts. They can improve their transportation network and run it more efficiently. This one is a great question. Sorry, I can't show you all the responses. Oh yeah, I can. This one's a great question. First glance, it seems that they haven't given you the answers to work this out, but don't be disheartened, we can do it. So what we see here, output 5,000, total cost is 15,000. We have to work out average variable cost, which is ATC minus AFC. So I can work out ATC already as TC over Q. So that's 15,000 over 5,000. That would give 3. So got that one. unfortunately to work out AFC. They haven't said they've given AFC, but they have. Because your fixed costs are always the same, but you don't pay any variable costs in the beginning. So your variable costs are 0 in the beginning. So if your variable costs are 0 in the beginning and your total costs are 10,000, that kind of means your fixed costs are 10,000. So here's a neat trick to find out your fixed cost. Just look at like the starting point. Fixed costs are 10,000 over output 0. Sorry, output 5,000. So 10,000 over 5,000. 2. So we are doing 3 minus 2 equals 1. I think we'll see another one like this, so you can double check you've got it. So monopolies, costs, and revenues, they are revenue maximizing. So the quantity is where MR equals 0. So your MR is 0 right at this quantity. The price that you charge is on your demand curve. So you go up to the demand curve, over to there, and this would be the price. So quantity is Z, price is K. And we are asked to work out profits. So profits is revenue minus costs. So is P minus ATC times Q. So the price is K. K minus, the average costs are M times Z. And if you worked out that box, it would be this box, that box. So it's K, L, M, N, giving you B. So this one's a bit weird, I guess, but what we see here is as a ship, quantity increases. Remember, like your economies of scale graph, as your quantity increases, your costs, your average costs are going to fall. Why? Because you can hold a lot more units of the good. The capacity has increased, so your average cost will fall. So I reckon this is showing economies of scale. Okay, so this one is D. So sales maximization. Remember, we're selling the most units you can without breaking a loss. So you need your revenue to equal your costs. So you could try and sell Q5, but you'd make a loss. So that wouldn't be sales max. And then you can try and make Q3, but you're not making the most quantity. You could have made Q4. So that's why it's sales maximizing there. This one's very similar to, I think, question 2. So you need to work out MR. So you need to literally work out the change in your revenue and the change in your quantity. So work out TR1 is P1 times Q1, which is 1.2 million times 4. Work out TR2, P2 times Q2, 1.1 times 5. The change in TR would be 0.7. You're just selling one extra unit. So that would be 0.7 million. And that's the answer. Okay, this one, the way I decided to go about this one is to maximize profits. Just set your MC equal to your MR. So I added like a little column here where I worked out MR. So this one is you're adding 8 extra revenue for 1 extra quantity. You're adding 7 and so on. And then add in a column to work out MC. And you want to just see whether these things equal. and you can see that they equal at quantity, some quantity between 51 and 52. So question 31, we have A at the maximum point on your total revenue. The gradient here is 0, so your change in your total revenue is 0 as you change your quantity, and that means your MR is 0. This one is a great one because you can actually work it out. You can add in the columns and work it out. So your average revenue, if you did this, would be 20,000, and then 19,000, and so on. You can work this out. But essentially, I've done enough to work out that your average revenue is not constant, and is in fact falling. And your marginal revenue, this changes by 18,000. That's a really bad 8. And then it changes by 16,000, so it's also falling. So we are looking at E. Yeah, sometimes you need to work out all of the answers to get the answer. Okay, with this one, I think you can work it out again. So you can work out marginal costs, average costs, marginal cost 400, 300, 200, average cost, that's infinity, 1,400, and so on. And then if you do that, you will get that the answer is, hang on, yeah, marginal cost is not increasing. Average cost, yeah, exceed marginal costs, yeah. So perfect competition, we're looking for the same products, we're looking for no barriers to entry, no barriers to exit. And I think if you want to make steel or a bank or telephones, pharmaceutical, you have huge barriers to entry. You need like the machinery, you need the trained people, that's huge. Whereas wheat, a lot lower barriers to entry. So this one's slightly a sneaky one. The way I went about this is I remembered that a demand curve like this creates a revenue curve like that. That's not in debate. So I think what they're referring to is just the initial chunk of this, the total revenue, where your demand curve is just this chunk. So demand curve is equal to your AR, so clearly your AR is falling. And remember, your MR would look like that with a downward sloping demand curve. So the answer is C. This is a seemingly very successful demerger where they are splitting two businesses that were not very similar. So they would be splitting them for like a reason they needed to. They would benefit by splitting it. So they must have been facing some kind of this economy of scale probably, and by splitting they can stop having those really high average costs. Okay, we need to work out average fixed costs. Now we know how to do it. So average fixed costs over quantity. To find your fixed costs, look at quantity 0, and here they are 10,000. So 10,000, output is 1,000, and then you will get 10. Okay, revenue maximization is at 4, yeah, because the revenue curve is the highest it can be. Here we're talking about lorries. Lorries get really, really big because you can run them at similar costs, but they have a lot more capacity. So food or anything transported in it ends up getting cheaper. So it will reduce long-run transportation costs. It's an economy of scale. Okay, so at point X, we have the MR, where the quantity is not 0. The quantity is something, but the value of the MR is 0. So here your MR is 0, that means your change in your revenue divided by your change in your quantity is 0. So your revenue isn't changing. So in other words, we're dealing with the maximum point, where your revenue here at the top is flat, not changing. Total revenue is maximized. Okay, so that's all the questions. Remember to look at the link below for the written solutions, and I'll also put in the questions. Let me know if you have any other doubts, any other video ideas. Happy to have a go at that. Thanks very much for watching. It's a long video, really worth doing these questions. They are really great. And yeah, good luck with the rest of it. Bye.